Hello guys. So I think I am audible. Yeah, so let's start the today lecture. Today is the day 5 of NLP, and basically we have covered all of these things like in NLP, basically text processing. Inside the text processing we will covered like uh, one hot encoding, bird to back, average bird to back, embedding. All of these things we have covered till now. And in the previous lecture, basically I have covered the architecture of RNN, like recurrent neural network, how RNN will work. I have covered till now. So today is the day 5, and basically I am taking the notes of Chris Naik. Chris Naik is the very best teacher. I will give sounds. Basically, my favorite teacher in deep learning and all of these things like I have learned from machine learning by Chris Naik. He's a very good teacher. You have to also follow this. I have also mentioned in my comment section. You can also go to the Chris Naik channel by directly by visiting. Yeah, so let's start the today. And today's agenda is basically LSTM RNN. I have covered in the previous lecture RNN like recurrent neural network, and today I will cover LSTM RNN, long short term memory RNN, like how this will work. And in the next lecture, I will cover the bidirectional LSTM RNN, how this bidirectional LSTM RNN will work. So before we start, let's see a one interview question like what is the difference between normal distribution, log normal distribution, and how they look like. So the normal distribution, we know that it's a bell-shaped curve, and approx 90% of the entire universe data set will be a normal distribution. If your data set has a normal distribution, then mm, your model will be very good. But if your data set will not have a normal distribution, then you have to your data like your model will not work very well, so you have to apply some transformation like box fox transformation is there, and like QQ, like many transformation are there, normal or Gaussian distribution. This like bell curve is also known as normal and Gaussian distribution. So if your data set has a pseudo distribution is like looks like this one. And so to convert this pseudo distribution into a normal distribution, we apply a box Cox transformation. Yeah, so that's it. And standard normal distribution is there. Like now the question is, if you have a left skewed and right skewed data set, then what is the relationship between mean, median, mode? So yeah, this is the very best question, and many interviews will ask this question. So this is basically a right skewed graph, basically we can say. So in that skewed, basically we have a mean from here. So in that case, mean is greater than median is greater than mode. So in this case of right skewed, in the case of left skewed, our mean will be there. So mode is greater than median and median is greater than mean. So this is the relationship between mean, median, mode. You can remember these things. Yeah. So that's it for this interview question. Now the second interview question is like, what is the difference between transform and fit transform? This is also a very good question. So the answer for this question is like the transform and fit transform is there. So we apply transform in our training data set and apply fit transform in our testing data set. Why we don't apply fit transform like in our training data set? To avoid the data leakage part. Yeah. So basically, if we apply a transform in our whole data, then there may be a condition like our model will basically there's a data leakage problem. So that's why we don't apply a transform in the testing data set. And predict method is also there. So yeah, normalize and standardization is also a question for interview. So in normalization, basically we will divide the max value from the dataset. Like suppose you are dealing with a CNN image architecture, like images, then we have to divide by 255 so that our value ranges from 0 to 1. And standardization is basically uh, this will have a mean equal to 0 and standard deviation equal to 1. Basically if you apply standardization, then your data set will follow a standardization. In the standardization, you have a mean equal to 0 and standard deviation equal to 1. Yeah, so that's it for normalization and standardization. There's are some questions related to statistics. Now let's start our RNN discussion. RNN, I have done it. Like, let's see, today agenda is LSTM RNN. So yeah, let's start from RNN. So I have already taught you, like, in RNN basically we pass at every time frame some input. Suppose we have a sentence length equal to 4, like my name is Narendra. So at the time frame of 0 we will pass Narendra. No, no, not that, like my. And at the time frame of 2, basically we pass my name. So at the time frame of 2, name is passed and the output of the previous layer, like my is converted in some in transformation is done by our model, like RNN model, and this output will be also passed as a output to this second input, second input model, and the new input are also passed at the time frame of 2. And the time frame of 3 we will pass again a third input, like my name Narendra is passed at the time frame of 3, and the output of the combination, or we can say the context vector of the previous output is passed here. We will pass the context vector, and the new input also passed at the time frame of 3, and this process again and again until our we will get out of end of string. Until that we will pass something like that, so that we will get our output as a context vector. But this approach is not good, like every time we have to pass a one input. So that's why this will take some time, so that's why nobody is using this model. And there also are some problem, like what the gradient pseudo, what I will say tomorrow. I said na, vanishing gradient, vanishing means small, vanishing means small gradient descent problem is there. So that's why we don't use RNN nowadays. We are using transformer. So in transformer the vanishing gradient problem is also solved, and the input now we are passing a one by one, the in transformer we can pass whole input at a same time. So that's the use of, like, benefit of transformers. That's why nobody is using RNN. Now in backward propagation, basically, firstly we will pass inputs same like this, and now we will calculate the error, like what is our loss for this model at the time, at the epoch of 1. And then we will say to model, "Okay, we are getting this much of error, so you have to adjust your bits according to this error, so that the error will be lost. So to avoid the error will be minimum, to minimize this error we have some activation functions. So these activation function will apply, so that we will get a good, like, minimum error. So in deep neural network we will use some, like, ReLU activation function to get a minimum error. And basically activation function is applied at the time of forward propagation. In backward propagation we have optimizers, like which optimizers we will have to use. So at the if we have a output, suppose a multi-class, then we use a softmax activation function. Uh, the optimizers to reduce the loss, basically we will use Adam optimizers. Basically nowadays, Adam optimizers is the best optimizers nowadays. The first optimizer is basically be known as a gradient descent, but gradient descent will not work very well. So now the Adam optimizer is the very best optimizers. Everybody is using Adam optimizer without knowing the knowledge of that, like how this. So in that, basically the our alpha is basically a learning rate is also get some momentum. Like at the initial he have some Adam, like alpha has a higher value. At the, like, after some number of epochs, it will the alpha, or basically learning rate will be minimum, so that the we will get our local minima as fast as we can. And also the your weight matrix is also have some momentum, so that you will get good answer at the right time. Bit of prediction formula we have already know that W n equal W out minus neta differentiation of loss function basis to W old. So and the chain due to chain rule of differentiation we know that the vanishing gradient problem will occur in RNN. Yeah, so that's it for the RNN. Now see the architecture of LSTM RNN, how the LSTM RNN will work. So remember something in LSTM nowadays many times we will use LSTM RNN or inside a transformer basically we use sometimes LSTM. The formula is LSTM is long short term memory. Wait 1 minute. Yeah. So the formula of LSTM is long short term memory RNN. So in LSTM basically we have a this upper layer you can see this known as a long memory or you can say a long term memory remember, and this the lower down you can see this known as a short term dependency or short term remember dependency. And this x of t here you can see this is your input cell, and here you can see this is your forget cell. We can say that what is forget cell. So okay, so forget cell is basically denoted by this f of t, and here you can see a sigma is basically your softmax activation function. Basically this is your activation function applied here, and 10h is also your activation function, and this is your sigma is your activation function. This is your softmax activation function, I think. If I am wrong please let me know. I think this is your, yeah, and this known as a forget cell and this known as a memory cell. C of t minus 1. What is C of t minus 1 and what is h of t minus 1? So h of t minus 1 is basically your output of the previous layer, and C t of minus 1 is also a output of a previous layer. But what is the difference between C t minus 1 and h t minus 1? So suppose the problem in RNN we have already discussed about, like it will not able to remember if your sentence length is very huge. Like the dependency of your he is on depend on the third sentence, then this can't be like RNN will not be able to predict it like whom I have to refer. But LSTM can refer it. Like how? So h of t minus 1 is same as like like RNN. This will remember this short term dependency. Like if your sentence length is 1 and 2, then this will able to remember. But ct minus 1 is basically a memory cell. Memory cell means your long memory cell, basically ct minus 1. So here you have to remember like many things. Like here I have to remember if your sentence length is even 4 or 5, this will able to remember all of these things. Like from the like this is a long memory remember cell, and this is your short term memory remember cell, we can say that. So if you send it like my name is Naren, to whom Naren is referring to my, so he can able to remember by ht minus 1. But ct minus 1 is remembering if your sentence length is even 4 or 5, this can be able to remember it. Now if you now so what happen if you pass a new input and the you have already output of the previous layer. So this here you can see this operation is known as concatenation. So here your both operation will be concatenated, like your short term remember cell output and your new input is passed and concatenated and passed through this sigmoid function, and sigmoid function is basically give you some output. Sigmoid function will give you a maximum output, and here you have suppose forget cell is there. So forget cell output and your like long memory remember dependency, like more long, we can say long memory context vector is there. So long memory context vector and your short term memory context vector. Here you have short term context vector and new, like new information will be passed, and you have already old information, and this operation will be uh, we have applied a point wise operation, cross operation we can say. So this no this operation known as forget cell. So here is basically the information will be captured, new information. If the information is new information is good, then your model will forget the previous information and new information will getting the captured. If your like new information will not have a huge impact, then this will be a point wise operation, so nothing will happen and your previous information will be captured automatically. So that's how this will work. So this is basically a very very important for like in the LSTM. This is the very very main important thing you have to remember it, like forget cell, because whole operation like new information is getting captured here. If the it is important like previous information, then it will be there, but if it is not important, then this will be removed. Like how this will be done, suppose you are doing a cross operation. If you do a cross operation between, suppose your old vector is 0.9, like very very good, like your value ranges from 0 to 1, so your previous output like your long memory context vector is value 0.9, and your new vector will come and its value from 0.8, then it will see, yeah, it's a new information and it's a good information. So if you multiply it, it will give you a very very high value. But suppose you have a new like old information which is 0.9, and and this time you will pass information which is not required, like 0.1 only. So if you apply like 0.0001, and if you multiply these two vector, then you will get a very very small value. So that's why this plays a very important role. So this will forget information and it will give you a very very small vector. That's how you will this will operation will work. I think you are able to understand it, that I have explained. If I will explain in Hindi, then it is good, but now I have to improve my English. That's why I am teaching in English. Please, guys, understand it. I have to improve my communication English. Please support my channel. I think in 1 or 2 months my English will be good, so you don't have any problem. Maybe in next 1 or 2 weeks, or maybe 1 or 2 months. I am good in communication. Maybe that's why I am started this channel. Please, guys, support my channel. Yeah, so we are there. So we have passed this information, and this information again, the same f of t. Here we again pass, like here input layer is there, and now again we have to give this information, and this in like 10. Firstly we will apply a sigmoid activation function, and in the second here again we will pass our 10h activation function, and both of these output will again we will get a pointwise operation. So that, so there here we can again get a new information, and this new information will be again concatenated. This operation is basically concatenation of the uh, long context memory vector and the new context vector again apply, and you will get some new output. That's how this will work. And that's here we can again point wise cross operation there, and again a 10h operation like 10h activation function is applied, and then again we will pass this info, so that we will get a long context memory vector. And this is your basically CT, and ST, like ST is basically remember, basically this is your low time memory dependency, or low context vector member dependency is there. So this will help us to remember the lower, or we can say a low context vector, and this is basically high context, high dependency context, or we say a long time That's why this name is LSTM, long short term. So this layer is basically known as long, and this layer is basically known as short. So long short term memory RNN. That's how this will work. And new context information is being get passed. And if it is important, then the forget cell will help us to what I have to remember and what I have to forget it. Here we have to apply sigmoid activation and point cross bias operation is also applied. Why HTML instead of RNN? Yeah. So this is the question. So in that RNN, we have already seen that there is a vanishing gradient problem or dead neuron problem is there. So this problem is solved by LSTM because we are applying a sigmoid activation tangent activation function. So this problem will be solved. And context info deep RNN huge gap. Yeah. So in RNN, basically recurrent neural network, if your sentence length is very huge, then the context it can't be remembered. Like who here I or whom I have to remember, like whom I have to refer. So this information is being also captured in LSTMs because of long-term dependency. It will like this layer is basically help us to like which information I have to forget and which I have to remember it. That's how we will able to capture it long-term dependency. So that's it for today, guys. Let's meet in the next lecture. Yeah, so I have covered today LSTM RNN, and in the next lecture basically we have see mm, LSTM RNN in-depth intuition. Yeah, so again we have LSTM RNN, but here we have to understand each and every step, like how this will work. Basically I have explained, but in the next lecture we will explain from in depth, like how LSTM will work, what is forget cell, how forget cell will work, all of these things we will like. And this the next lecture will be the end of this NLP, and that's it for NLP. May I think I have explained everything. Yeah. So thank you guys. Please hit and subscribe my YouTube channel. Please help me to grow. Nowadays I'm getting some good number of subscribers. Thank you guys for support me. Love you guys. Let's meet in the next lecture and see how our channel will grow. I think I have to start from scratch. If I will explain everything from scratch, then this will be fine. So I am planning to start everything like from statics to machine learning, deep learning, everything from scratch and in-depth intuition, like everything from scratch and explain in a very good manner. I think it will work. Thank you guys. Let's meet in the next lecture. Jai Hind, Jai Bharat.